And welcome to the Daily Space Weather Show. I'm your host, Dan, aka Smash-O-Mash, and we've got massive sunspots facing the Earth, a very high likelihood of large solar flares. 3 new groups that we talked about in yesterday's video that aren't named yet, and the most important sunspot might be this little modest one down here in the southern hemisphere. We'll tell you all about it. And lots more here at the Smash News Network, least busted name in news. We're going to start out with the Western Limb. The most likely place to see a large flare like an X-class event is up here in the northwest. That is one huge sunspot group, and as it approaches the limb, its statistical probability of producing large flares is going up. So that's the first thing to talk about. And there's a close-up of that group. How you like them apples? Next, let's move to the southern hemisphere and talk about that modest sunspot at that extremely low southern latitude. That is an indication that we still aren't at solar maximum. So at solar maximum, we see sunspots at all latitudes, around the equator, as well as closer to the polar regions like this one is. So there is also one over there in the west that's a new group. So we'll have 4 new named sunspot groups today on September 10th. So here's a little closer view of that very low latitude sunspot, I guess I'll say. It's a very high southern latitude sunspot. There we go. That makes sense. In other words, it's far away from the equator. And again, when we see solar maximum, we see sunspots at all latitudes. After solar maximum occurs, then we see less and less sunspots at these high latitudes. And at solar minimum, we only see sunspots around the equator, for the most part. So there's that new group. And then we'll take a look at the equatorial view. We have a huge sunspot right in the Earth strike zone there. So right above our Earth scale, there is a very huge sunspot. And of course, you can see activity in that group to its east also. Here's a close-up of that huge group right on the center of the solar disk there as far as longitudes go. It is a large and magnetically complex sunspot group indeed. And last but not least, we'll take a look at the Eastern Limb. Again, we have 3 new groups there. We talked about them yesterday. They'll get named shortly today. I think we're going to actually have 5 new named sunspot groups today. So there is a close-up of that Eastern Limb. The most significant one is the one north of the Earth scale there. The one closest to the equator. So here's a quick look at sunspots from the SDO continuum that depicts yesterday plus today. So we'll have a new group down here in the southwest, a new group down here in the southeast rather, and then 3 new groups right on the Eastern Limb. Exciting stuff. Here's colorized magnetogram yesterday plus today, September 9th and September 10th to date is what those are depicting. And thanks to our new subscribers. If you enjoy the content, don't forget to press the like button. If you're new to the channel, press subscribe. We are the world's most comprehensive daily space weather channel and also the most detailed solar imagery you'll find. We throw in the meteorology segments at the end as a value-added service. I discovered 2 decades ago that it's way too easy to forecast the weather. I needed a better challenge, and to advance cosmology, I decided to jump all the way in to the realm of solar forecasting, heliophysics, and so on. Again, because of the implications on cosmology, I'll just leave it at that. Don't forget to press like, leave a comment. Thanks to our new subscribers once again. And thanks to the Smash team. So let's see what's going off with volcanoes. We have a much longer list than we did yesterday. Shivaluch, volcanic ash not identifiable in satellite imagery. Well, that's not very exciting. Abico, producing a 10,000-foot plume of volcanic ash, flight level 100. Please do not pole vault the caldera. If you're going on a volcanic vacation, leave your vault pole at home. Subanose-jima also erupting to 8,000 feet. Unknown cloud over Mount Mayon, Philippines. Discrete eruption there from Krakatoa as it explodes. Flight level 040. It's a 4,000-foot plume of volcanic ash. Don't pole vault Krakatoa either. It's the daughter of Krakatoa. Dakono, 8,000-foot volcanic ash plume over Halmahera. 20,000-foot ash plume as Popocatépetl explodes in central Mexico. Flight level 200. Flight level 210 over Colombia from Nevado del Ruiz. Revenador exploding in Ecuador, flight level 140. Flight level 220 over Sabancaya in Peru. There ends our volcanic list. Sabancaya is exploding. It's a 22,000-foot ash plume. We have seen a continued uptick in seismic activity following the 6.6 magnitude quake in Morocco that killed thousands and knocked ancient buildings off of their foundations. Largest quake of the past 24 hours was a 6.0 at Palau, Indonesia. That occurred at 14:43 Universal Time yesterday afternoon. We'll call out the rest of the quakes of 5 or greater magnitude. And it looks like things have calmed down here a bit following about 36 hours of quite extreme seismic activity on a global scale. So that's it. No other quakes of a 5 or greater magnitude to report. Headed back to space. The filament situation is also quite significant. So that's what's going on with filaments. That's 193 plus 304 angstroms SDO, 24-hour video. There are a huge number of very large and very dense plasma filaments, a very high likelihood of large solar flares, and the likelihood of coronal mass ejections is about 100% moving forward here. So here are some stats. The 10.7 centimeter radial flux still at 161 solar flux units. So it has leveled off there at 161. That is the 1-year graph. The black line is the 10.7 centimeter radial flux, also referred to as the F107. Space Weather Enthusiast dashboard forecasting some geomagnetic unrest here just before midnight on Tuesday, September 12th. So that's probably a coronal hole high-speed stream, I would suspect. It doesn't really say anything about it. So I suspect that's a coronal hole high-speed stream there on NOAA's forecast. No arguments from me there. We do have some significant near-equatorial coronal holes at the moment. Next Earth's magnetic moment from space. This is our 4-hour geospace magnetosphere movie. And geomagnetism on Earth is very calm at the moment. We did see a weak coronal hole stream, which we'll talk about here momentarily. First, Earth's magnetic moment from the ground. Now, keep in mind we usually show the flat globe view, but it's, as you can see, it's a little jacked up. So we're going to show the polar view instead, and it's suboptimal. And I think it's because of some missing data there on the solar wind, as the geospace magnetosphere movies use lots of different sets of data. And if you're missing a data set, you're going to have jacked up imagery. So don't pay too much mind to that. Let's move on to the KP index, which is currently at 0.67. So again, quite geomagnetically calm. We've got a weak solar wind. And we did see this coronal hole high-speed stream. It was very short-lived. And here we're getting a very different solar wind there from the Discover and the ACE. So the ACE was picking up 442 kilometers per second, and the Discover was only picking up 345 kilometers per second. So, but they were showing a similar density there. So another indication of how differently you can see the two spacecraft both orbiting Lagrangian point 1, reporting very different conditions there. The same density approximately, but very different solar wind speeds. Density did make it up to about 11.5 protons per cubic centimeter. It looks like a coronal hole high-speed stream, but a very weak one. All right, we have some data kicking back up here. What do we got? A little bit of data there showing up here from the Discover. 322 kilometers per second and a little under 2 protons per cubic centimeter for the solar wind. GOES magnetometers here quite smooth as you may expect. No action going on as far as space weather. Next, our top view ecliptic plane field plot. Earth is right in a south pole current sheet. Kind of right in the center of that south pole current sheet there, and the eastern limb of the sun is holding pretty steady magnetically speaking. It's got sunspots in the north and southern hemisphere and one right on the equator. So don't expect any rapid changes in that unless we see some rapid changes in sunspots on the eastern limb. Sector boundary still several days out, at least a few days out. So Earth is right in the center of that south pole current sheet. And here is our line of sight field plot. The B field will look all fanned out there, as it's known to do when you're right in the center of a current sheet. Solar B field here depicted in blue. Red for south, green for north polar fields. And the grayscale is the gong magnetogram of the photosphere. Let's move to coronal holes. And as you may expect, lots of south pole oriented coronal holes here. We do have some north pole ones also there in the southeastern limb. Let's take a look at those through the perspective of the Solar Dynamics Observatory. So these north pole coronal holes down here will become more well defined in the coming days. These are south pole oriented coronal holes. And I would tend to agree with Noah that we may see an uptick here in the solar wind parameters. Probably sometime like midday on Tuesday. The high-speed portion will show up later in the day on Tuesday. So that's the scenario for coronal holes. I find them extremely important to the solar cycle. Sunspots, also, I guess you could say, kind of important, right? So we've got 1, 2, 3, 4 sunspots that are about to get named today. That'll be 34, 28, 29, 30, and 31. So 4 new named groups. Likelihood of major solar flares extremely high here. Check this out. 55% chance for a 42% chance for an X-class flare and 46% chance for an M-class flare from that sunspot almost right in the center longitude there. That would be 3423. Also a very high likelihood, in my opinion, in the northwestern limb. Let's take a look at sunspots here from SDO. There's the continuum for the past 24 hours. Also, this group up here is capable of producing large flares. It has been quite active. And there are filaments galore, and it is just exciting stuff. We had a very low amount of coronal mass ejections in the past 24 hours, a surprisingly low number of coronal mass ejections. We'll talk about the forecast for that in a moment. Next, we're going to talk about energetic particles and solar flares. We don't have any energetic particles. The proton flux is flatlined. As far as X-rays go, we've gone back to a C-class background level of X-ray flux. Something like a C1.2 background flux there. And we've really seen a shortage of solar flares for the past several days. Largest event was about a C8. That was at 2 o'clock this morning on September 10th. Here's 94 angstroms for the past 24 hours. We've got the Earth scale on that side beneath that huge sunspot that's setting in the northwest, because it is still my favorite place for a large solar flare. We could also see a large flare on the eastern limb or on either of those two large groups in the northern hemisphere. So flare watch in effect. Bigly. Yeah, bigly. It's huge. It's huge. Okay. Here's 131 angstroms. The other wavelength that takes 10 images per minute instead of only 2. It's got a 5 times higher temporal resolution, and it's specifically formulated to watch solar flare activity. Another 24-hour video from the Solar Dynamics Observatory. And what's next, you ask? Well, what's next is a star chart. We use skyandtelescope.org for hours. And if you're up before dawn, you might see Mercury, a crescent moon, and Jupiter up there in the early morning sky. Mercury will be visible if you have low light pollution, a low horizon, and clear skies. Today's astronomy photo of the day is an annular eclipse. And those annular eclipses, they happen because the moon is farther away. So when the moon is farther away in its orbit, it's unable to cover the entire sun. So sometimes you get this awesome crescent. Sometimes you get a fiery ring. apod.nasa.gov if you want to view the astronomy picture of the day yourself. And here comes your solar system forecast. There's where heavenly bodies are today. There's where they'll be in 1 week, on the 17th. I think people will soon be spooked because the Earth is moving past Jupiter. They think it's going to do a thing or something. So get ready for all the spooky spookiness of the Earth moving past Jupiter, which it does every year and nothing happens. And here are our coronagraphs. So again, a very light activity as far as coronal mass ejections. And that is not likely to continue. In fact, it's not going to continue. Expect CMEs in the next 24 hours. Now, that's just basically a statistical analysis, folks. That is not any kind of... it's just basically a statistical analysis. I mean, we've got huge sunspots. We've got a high likelihood of solar flares. And we've got a lot of filaments on the Earth-facing portion of the solar disk. Those factors never continue to hold out. They eventually lead to coronal mass ejections. So here we've added LASCO C3. Again, it has been a very uneventful day, although there is one interesting CME there coming out of the North Polar region. So it's kind of a more of an outflow event than really a proper CME. And before we show our custom movies, we'll also show stereo A difference imagery and stereo A's raw coronagraph. There you can see a great view of that outflow from the northern polar region. And there actually is a crown prominence at both poles at the moment. There is a north and a south pole crown prominence where a filament hangs off the edge of the solar disk. And let's cut to our custom coronagraphs. Before we do that, we'll pause for station identification. You've reached the Smash News Network least busted name in news. Here's a 24-hour video featuring 193 angstroms, as well as SOHO LASCO C2 and C3 synchronized. We'll zoom in a little bit closer. Don't be shy. Once again, thanks for staring at the sun. The best way to get answers to questions not asked, folks, is to immerse yourself in the data. That's why we cover so much on the channel. I might not sound excited, but it is quite exciting indeed. I find myself able to be stoic in the most extreme situations. So let's take a look at those filaments, and yowzers. Look at the filaments there. We've named this one down here Eugene Bagashov after my pal from Minsk. And let's see, we've got 1, 2, 3, 4, 5, 6, 7, at least 7 other filaments that could get names. That is the ground-based El Teide Spain hydrogen alpha imagery. Dag. That is a lot of filaments. What do you say, folks? Leave us a comment and tell us how many. Tell us who you'd like filaments named after. And then go join us over on Twitter if you'd like to actually name them. We name filaments after living people in the spirit of naming storms. Since even winter storms are getting names nowadays. We show the gray imagery here also because it shows prominences. So you can see crown prominences at both poles, as well as on both the western and eastern limbs. Exciting stuff. And thanks to our new Twitter followers as well. Go follow us over there if you haven't entirely unplugged from social media due to the pathetic censorship by the 4 evilest companies in the world: Alphabet, Apple, Meta, and Twitter. Here are the past couple of hours from the GO 16 SUVI, and you can see those prominences. Prominences, filaments, large sunspots, very high likelihood of solar flares. It's the calm before the solar storm, folks. It's the calm before the solar storm. Them is the facts. And let's do our bonus features segment before we get to meteorology, because there's important meteorology stuff to cover as well. So as far as charging hazards, we ain't got none. It's smooth sailing for satellites there. No surface or internal charging. No high or low energy electrons affecting spacecraft. The GOES electron flux here, kind of low levels. Looks like a further dip from yesterday. That's the 3-day chart. Here is the 1-year chart. So low to moderate levels of relativistic electrons there at the F layer of the ionosphere. Here is the forecast model. NOAA expecting even lower levels. So yeah, there's some coronal hole plasma headed this way. That will be the next space weather event, coronal hole high-speed stream, preceded by a density wave. Next, the layer where that's measured, the F layer. Feel free to pause the video on this frame if you're not familiar with atmospheric temperatures, the penetration of electromagnetic radiation, and atmospheric chemical concentrations. Here is the F layer of the ionosphere and vibrational frequency, megahertz. And basically, we are seeing a lot of high-frequency anomalies here, actually. So quite a lot of high-frequency anomalies here, the opposite of what you typically see during space weather events. You see lots of low-frequency anomalies. So here we're seeing fast vibrations at the F layer instead of slow ones that you see when it's, in other words, it's like seeing not a lot of space weather. It's a very geomagnetically calm situation. Here's the anomalygram, and again, you'll see a lot of blue on this. A lot of blue there. It shows high-frequency anomaly in blue, low-frequency anomaly in red. It's the anomaly in megahertz from a 30-day median. Anyway, here's the latest image. That's 1045 universal time, raw vibrational frequency, and 1045 universal time anomalygram. Again, lots of blue there. Lots of high-frequency anomalies on the F layer. We show total electron content as well. It's useful for everybody who uses GPSs. Your GPS satellite must communicate through free electrons, and when it does so, you can get signal refraction. Signal refraction of thousands of miles sometimes. And here is the total electron content. So that's the free electrons from about 12,500 miles of altitude down to your ground-based handset. And things are fairly orderly when it comes to the total electron content today. We'll also show the total electron content over North America, the anomaly from the 10-day average. So we do see the subsiding of some high electron content anomalies over the west coast of Canada there. But we are seeing some over northeastern Canada this time. Also the Caribbean. They are less pronounced electron anomalies. We'll close out the space weather section before we get to the weather on Earth with the latest magnetogram and latest intensitygram. So again, we've got 5 new sunspot groups. There's one. Make it 2. Make it 6 new sunspot groups. Check it out. There's another one ahead of this one. So there's 1. There's 2. Headed over to here to this really high latitude one. There's 3. And then the eastern limb. These don't have names yet. There is 4 and 5 and 6. So big uptick coming in the sunspot number. This group here is, according to the flare monitor, the automated one, the most likely place to produce large solar flares. It is beta gamma class barely. Beta gamma delta class barely, rather. It's definitely beta gamma class, but it doesn't have a lot of significant deltas. So the most active group over the past 24 has been this group, and it is actually more magnetically complex than the one in the Earth strike zone there. That one there, more pronounced in terms of its deltas. So that is a better sunspot for large flares. My favorite place for a large flare remains the northwestern limb, so we'll show that. There you go. And as far as those eastern groups, the equatorial one is, I believe, the most active. We'll show all of them anyway. That one's got some tightly packed umbrae there. Let's see here. That one's barely even beta gamma class. That one there is magnetically complex. Anyway, let's move on to our meteorology segment. We don't want the video to be too lengthy after all. So we're going to start out with just a brief view of what's going on Earth's wind patterns. So here are the jet streams of the eastern world. Very strong jet stream there over Australia. Here are the surface winds for the east. Like sands through the hourglass of time, these are the surface winds of the central world, Europe, Africa, and the Middle East. Here are the jet streams of this portion of the planet. The jet stream blowing backwards there over the northern Indian Ocean. Here are the jet streams of the west. And that Atlantic hurricane is still running into some problems with getting organized. Here are the surface winds of this side of the planet. And we're going to show you a forecast for this hurricane. We talked about it yesterday, how it's running into some issues. So all the catastrophists, sorry catastrophists, it's not looking, it's looking like that hurricane still has some serious hurdles to overcome. So here's your forecast. We're going to first show the windy.com forecast. So we've put in the pressure isobars there. And this is the Euro forecast. We're going to do 3 days out Euro forecast. That is where things will be Wednesday according to the Euro model. And you can see it's actually weakened again there. It's kind of spreading out. It is moving into some dry mass of air, so that's not going to really aid in its convective processes. The GFS forecast puts it a little bit farther to the northwest, but a similar forecast there on the Euro and the GFS models. So again, there's GFS, there's Euro, that depicts wind speeds and pressure. The pressure only expected to be about 950, the high 950s, low 960s there. No major intensifications. And we'll show you why here in a minute. Here's the full Earth view of clouds and fog. And we're going to show closer zoom-ins for that hurricane. So there is the latest. And here's the water vapor map. And again, it's entrained in a bunch of dry, massive air there. So that does not help These are all relative highs. Since nitrogen is more massive than water vapor, so those high pressure zones are something that are working against the organization of that low. That's just the way it works, folks. So let's take a look at your weather.gov map, the National Weather Service homepage. West Virginia and Virginia expected to see some flooding. We'll cover forecasts for that. Here's pressure and precipitation for the lower 48. And there is total accumulated precipitation for the lower 48. Looks like Pennsylvania is going to get some significant rain as well. Also some heavy rains in the central part of the country like Texas, Oklahoma, Kansas. Heaviest rains, like 2 feet of rain to fall in the Atlantic. And next here is your North Atlantic forecast. This other system's going to start moving due north. And this system's going to keep moving to the northwest for now. We only show 3-day forecasts because they tend to be accurate. That's a 72-hour GFS pressure and precipitation forecast for the North Atlantic. Last but not least, the jet stream. Since the jet stream controls the weather in many ways, there's your 72-hour, 250 millibar wind speed forecast. The jet stream for the next 3 days. And it looks like it may start to affect that hurricane in about 4 days. Anyway, here's your lightning mapper. This is where the strikes have been. Texas. Looks like it's the lightning capital of the U.S. for the past 10 hours. And here is our lightningmaps.org plug. Real-time lightning maps are awesome. Next time you hear thunder, I highly recommend you check it out. You want to be able to forecast thunder like a movie villain, or maybe you want to convince the natives that you're Zeus or Odin or something like that. lightningmaps.org. It's highly recommended. It's also highly recommended that you support this channel if you'd like these videos to continue to exist, remain publicly visible, and free for all to view. The Smash News Network officially thanks the Smash Team, as these videos are brought to you in part by the Smash Team, especially gold and silver members. There's even a bronze membership level if you'd like to pay $0 a month and still receive email alerts about videos just like this one. If you want additional content, join at the silver or gold level. Those are our preferred levels. The best value is the gold annual paid-up subscription. Smashomash.com/SmashTeam to support the channel. It's almost like Patreon, just better. It's our own site. We do things ourselves around here. And we say Universum Liberate. Why? Because it's the motto, or you could say the tagline, of the Galactic Federation Special Forces. Universum Liberate. If that sounds too reckless for you, then you must be frightened of freedom. Yeah, it's very scary. Oh, noes. We don't want people to be free to do what they want, do we? No, of course not. However, you deserve it. So enter the promo code You Deserve It to save 40% on your Galactic Federation Special Forces gear. If it looks like a unit patch, it's because it is. It's symbolic. The key represents signal strength and integrity. The lightning bolt represents instantaneous galactic scale reach, and the spiral represents the galaxy itself. This little flash up here in the upper right, that represents classified. Today's featured product from the Hemp Lucid shop, another one of our paid affiliates/sponsors, is the orange-flavored organic full-spectrum water-soluble CBD. So check that out. It also comes in mint and natural flavors. This is the most popular product from Hemp Lucid. I believe the natural flavor might be the most popular, but we're featuring the orange today as I've tried it, and it tastes deliciously. The water-soluble CBD there from Hemp Lucid, linked below the video, as well as on the homepage at smashomash.com. So check the video description for that. You'll also find a link to the Amazon shop, which is amazon.com/shop/smashomash. Today's featured product is in our camping supplies list. Life Straw. If you're going camping and you don't want to haul your own water, but you know you'll be near a water source, drink all you like with Life Straw. Drink right out of the creek. It's going to remove most of the things that you don't want to be drinking. And it'll last for 1,000 gallons, by the way. So that That should be able to support you for a weekend and more. If you want to drink puddle water, I've heard Life Straw is appropriate. So try it out. Let us know if you did in the comments. Again, you can find links on the homepage at smashomash.com, the official homepage of the Smash News Network, least busted name in news. In 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you definitely can, because you can go to a website. Since you can see this video, you obviously have the internet. So smashomash.com/smash team if you'd like additional content. We'll close out with the latest U.S. Doppler radar, clouds and fog, and water vapor. There is the full 50-state view. It's showing vertical motion in the air column. That's what a ground-based Doppler radar system does. And if you understand atmospheric physics, you can forecast your own weather. Isn't that great? Next, clouds and fog. As that Atlantic hurricane comes into view on this map. And again, there's water vapor. All of that dry mass of air there in between the U.S. and that hurricane is a good thing. It will not aid in convection. I can't say it enough. Here's your recap, U.S. Doppler radar, as we bring you the weather in space and the weather in Earth. Space weather and Earth weather together. There is the clouds and fog view, infrared radiation at 3.9 micrometers. And there is the water vapor view, showing all of the water vapor. It shows you moist areas. It shows you dry areas. It's 6.19 micrometer infrared radiation. And it's time to close this thing out. So once again, thanks for tuning in. Thanks to our new subscribers on YouTube. Congratulations on realizing the channel exists. We'll see you next time. In the meantime, I've been your host, Dan, a.k.a. Smashomash, and may that's all. Let me try that again. May that solar wind be at your back.